Quick question that seems kind of apropos of nothing. A bushel basket contains 50 apples. I come to school with 1 apple in my lunch. How many bushels of apple do I have? I have 1 apple. 1/50th of a bushel. 1/50th of a bushel. Hold that thought. It turns out that when we're measuring charge, we use a unit called the coulomb. Now the coulomb is a huge amount of charge. If we had 1 coulomb of charge in this room, it would destroy the city of Bozeman. There would be lightning and thunder and just mass destruction, cats and dogs living together, Armageddon. Okay? Now, why did we choose a unit that was so unattainable and so unusable? Well, historically, we chose the unit of 1 ampere first. 1 ampere is the amount of current that flows through the wires in a standard household appliance in your kitchen. It's a perfectly reasonable unit for the flow of charge. Now, it turns out that that unit was chosen first, and it was chosen to be useful. But because of that choice, we get stuck with the choice of 1 coulomb being this huge amount of charge. Indeed, it's the amount of charge you would have if you had 6.25 times 10 to the 18th naked protons sitting in a pile in the middle of the room. 6.25 times 10 to the 18 protons. Now folks, I go back to the apples. If 50 apples is 1 bushel, and you only have 1 apple, how many bushels do you have? 1/50th. So I would ask, you've got 1 naked proton, 1 proton, you brought it for lunch. How many coulombs do you have? How are you going to find that number? Yes, you take that number and you say the charge on 1 proton is equal to 1 over 6.25 times 10 to the 18 coulombs. Now, if you plug that into your calculator, what you end up with is 1.6 times 10 to the minus 19 coulombs. And we call that the elementary charge. Now, unfortunately, the word elementary starts with the letter E. And so beginning students tend to think of that as the electron charge. That is not the electron charge. That is the elementary charge on 1 single naked proton. Okay? We typically, we notate charges with a Q. And the charge of a proton is E, or 1.6 times 10 to the minus 19 coulombs. The charge on an electron is minus E, or minus 1.6 times 10 to the minus 19 coulombs. Okay? So again, I hope this is review for everyone. Now, let's just see how big a fraction this is. So we define the charge on 1 proton to be that elementary charge, and the charge of an electron is minus E. Redundancy there. Here's my question. If a penny contains about 2 times 10 to the 23rd protons and an equal number of electrons, if we were to somehow charge that penny up to 1 coulomb, and it'd be foolish to do so, it would destroy Bozeman, but what the heck? In the name of science, we do it. What fraction of the electrons have been added or removed from the penny? First of all, were they added or removed? They're removed, okay? And the fraction is going to be the number that we removed divided by the original number that we have. Now the original number is given in the problem, 2 times 10 to the 23rd. If I want to make 1 coulomb of charge, net charge, I have to remove 6.25 times 10 to the 18 electrons, leaving that many naked protons behind. Now if I do that division, I get 3/1000ths of 1%, a tiny, tiny fraction of the electrons that were contained in that penny. And that's to get it to 1 coulomb. Typically we charge things to microcoulombs, which is 10 to the minus 6 coulombs, or nanocoulombs, which is 10 to the minus 9 coulombs. Okay? We never really charge something up to a coulomb, because we're not stupid.